Z1 is equal to 2 plus 2i, and Z2 is negative 3 plus 4i. Plot the complex numbers on the Argonne diagram below. Use a vector to join the points to the origin. It's normal to represent complex numbers as vectors, as I've mentioned before. So 2 plus 2i is represented at 2, 2. So this is Z1 just here, and here's a vector. Z2 is at negative 3 plus 4i, so that would put Z2 just here. And let's put the vector on for that one. Okay. We want to calculate the angle that each complex number makes with the positive real axis. In other words, this angle just here for Z1. Now, of course, we know that this is an isosceles right-angled triangle, and therefore that angle would be 45 degrees. We would write arg Z1 is equal to 45 degrees if we were working in degrees, or that arg Z1 is equal to pi by 4 radians if we're working in radians. Now, this is the principal argument. Often that is represented with a capital A, but it's a distinction that I haven't really seen made in specialist maths. So let's not worry about that at the moment. Now, the angle that we want for Z2 is going to be this angle just here. Now, it's relatively straightforward to work out this angle. We know that this triangle is 3 and 4. So, let's start in degrees, and we know that that angle there would be the inverse tangent of the opposite, which is 4, over the adjacent, which is 3. And so that would be 53.13 degrees. Now, clearly, the angle that we want is 180. Take away that last answer, and so we'll give that as 126.9 degrees. So we'll say arg Z1 is Z2, is equal to 126.9 degrees to 1 dp. And that's obviously in degrees. We could also, of course, work in radian mode, and we did the same calculation in radians, we'd get 0.927, and then we would need to do pi take away the last answer, and that would give me 2.214. So we could say arg Z2 is equal to 2.214 radians, and that would be to 3 decimal places.